So today we're going to start for 2.7. 2.7 is combining function. I mean, like we start already for this section from last time, but we did not finish this section, functions. Combining functions. So let me remind you what we did last time. So here, we have two functions. The first function is f, let f. And the second function is g, let f and g be a functions. Functions with domain. So the domain for the function f is a, and the domain for the second function g is b. Now, by using the rules, the first one says f plus g of x is equal f of x plus g of x. Second one, f minus g of x is equal f of x minus g of x. Number three, f times g of x. This is the product. F product g of x equal f of x times g of x. And number four, the quotient, f quotient g of x is equal f of x over g of x. And this is similar as f of x times 1 over g of x. And the domain for this one here, domain is the intersect between the both domains for the first function and the second function. The domain for the first function is a, the domain for the second function is b, the domain for the sum between the both function are the intersect between the both domain. The same things for subtract. Domain here is a intersect b. Same things for product. The domain is the intersect. But for the last one here, like I said last time, the domain is the intersect, but we have to remove the x, the zeros of the g of x. So x belongs to the intersect, a intersect b, but we have to remove the zeros, g of x not equal 0. We have to remove the 0 for the denominator function, g of x. And last time also I gave example, but let me give you another example, easy one. So the example now, suppose I have two functions, let f of x equal 1 over x minus 3, and my second function is g of x equal square root of x. Now the question is find f plus g of x. This is number one. Number two, find the domain of f plus g of x. Who will do the first one and who will do the second one? f plus g of x. Find the domain of f plus g of x. Who do the first one?
Is the first one just f of x plus g of x? Is that the answer?
Yes, exactly. So the first one, like he says, here, number one, f plus g of x is f of x plus g of x. Now, what's f of x? 1 over x minus 3. Plus, what's g of x? Square root of x. So f plus g of x is 1 over x minus 3 plus square root of x. Second one, find the domain of f plus g of x. Find the domain for the first one. So the domain, like I said, is the domain of f of x intersect the domain of the second function, g of x. So what's the domain of f of x? F of x, by the way, is 1 over x minus 3. Let me write it again here. F of x is 1 minus x minus 3, and g of x is square root of x. What is the domain for f of x? What is it?
So all real numbers except for 3.
Perfect. Thank you so much. This is nice. And Angel, he said all real number, not 3. Yes, this is right. So the domain for f of x, this is mean what value can I put inside the function and keep me the function defined. If I plug here any number except the zeros for the denominator for this fraction will be work perfectly. So the 0 for the denominator here is a 3. So if I plug any number except number 3, the function will work perfect. So the domain for f of x is x such that x not equal 3. This is mean all the element except number 3. Now I draw a line. Draw a line. This line. This is the real line. And the real line, I remove 3. So this is here the 3. This is 3, and all elements are in the domain. All the elements are in the domain. Now for the domain of g of x, what's the domain for the g of x? 0 to infinity. Yes, Elder. Domain of g of x is all element x such that x is greater than or equal 0. This is mean from 0 to infinity, I can plug any element from 0 to infinity inside the g of x. I cannot plug any negative numbers inside the radicals because they give me undefined values. Again, I have to draw the real line. This is my real line. And from the zero, here is number 3. This is 0 here. This is 0, goes to infinity. All elements from 0 to infinity. Now, the domain of the function f plus g is the intersect between these two lines, between the both domains. Here is the 3, okay? So I have to draw the domain. Now the domain for f plus g for x is the intersect. So this is mean I have to draw a line, the real line. This is my line. And I find that I'm looking for intersect. So look, the intersect is from 0 because the 0 intersect between the both line. 1 is intersect, 2 is intersect, the 3 is not intersect. Any minus number, here the minus, the negative numbers is not intersect because here we have negative numbers. Here we don't have negative numbers in the domain, so they are not intersect. They intersect only from the 0 to infinity, but we have to remove this point because this point 3 is not intersect at both line. So the domain is from 0, as we're looking for, is 0 goes to infinity, but here we have to remove the 3, then continue to infinity. So here is 3, here is 0. So the domain, it would be like the closed interval, no, not the closed interval, is x such that x is greater than or equal 0, but x not equal here and here and in the same time x not equal 3. All the value is greater than 0, but x not equal 3. The 0 is the number 3 is expect of this interval. So this is the domain for the function f plus g of x. Makes sense? Understand how to find the 0? Is it clear? Okay. Now, the same things for subtract. The domain, the same things. And the same things for any multiplication. But for the quotient, I'm going to give you as exercise. So now, exercise for you. Find by using previous example f quotient g, number 2, the domain. But let me give you a hints for the second one. The hints here for the domain is exactly the domain for the summation, but we have to remove the 0 for the second function. We have to remove the 0 for g of x. What is the 0 for g of x? Is 0. So the domain will be x greater than 0 and x not equal 3 without the equal here. Without the equal. Why? because 0 is the 0 for the second function g of x, the absolute value. Because if we're looking for the 0 for this function is x equals 0. So we have to remove this point from the function, from the domain. Okay. So this is exercise. I keep it for you. The same steps like before. Any question for the previous example for this one? How to find the domain and how we can find the summation? Okay, I hope it's clear for you. And this is exercise for you. I'm not going to do it. Now. So now we're going to learn something in new stuff. It's called the composition of functions. So here, composition of functions. What does that mean? Let me give you the definition, the general definition. Then I'm going to give you example about this definition to explain what does the definition says. So let we have like two functions. So the definition, let we have two functions. F and G. So we have two functions, F and G. Okay. Okay, let we have two function F and G, these two function. So now let me composite function, the composite function F circle G is defined as. So when you see something like that, F circle G, this is mean a composite function. So the definition for this function is look like this. F circle G of x is equal F of G of x. Okay. This is the definition of F circle G. This is a composite function. Now, let me give you an example. So the example is, let f of x, suppose I have two functions. The first function is f of x equal 4x minus 2. And the second function is g of x is given as 5 minus x squared. Now the question is, find f circle g of x. Let me put here, find f circle g of x. And second things, find g circle f of x. We'll do the first one. We'll do the first one, f circle g of x. Yes.
So first of all,
what's the formula?
4 times 5 minus s squared minus 2. Close
Can you
parenthesis.
give me, okay, so, good, perfect, but I need to do it step by step. Can we do it step by step? Like, what's the formula for this one? Angel,
It will be 4,
f
wait,
of
5,
f of what? G of x, what is g of x?
5 minus s squared.
Okay, nice. So first of all, we write the formula f of g of x. Now we plug the g of x inside the parentheses. Angel said f of 5 minus x squared. We get this function from here. We put this function inside the function, inside f. Then what you have to do, Angel?
Then we substitute that into the formula f of s, 4s minus 2.
Yes. Nice. Now you plug this one inside f. Instead of x, you plug this one inside x. 4 times 5 minus x squared minus 2. What you get? Yes, Jill?
20 minus 4s
20
squared.
minus 4x squared minus 2.
Minus 2.
Then what is that answer? 20 minus 2.
18.
20 minus 2 is 18, right? Minus 4x squared.
Yes. 18.
Can you hear me?
Yes.
Yeah.
Okay. Sorry for that. The connection is bad. So now let's go back to the example. So here, last things I said, a function f of x, the example is f of x equal 4x minus 2. The second function g of x is equal 5 minus x squared. And the question is find f circle g of x and find g circle f of x. This is number 1. This is number 2. So for number 1, find f circle g of x. Like Angela, he said, this is f of g of x, and this is equal f. You plug g of x inside the function. I mean, you plug this one inside the function, f of 5 minus x squared, like Angela said. Then you plug this one inside the function f. Instead of x, you put this one. This is equal 4 times 5 minus x squared minus 2. Then we get 20 minus 4x squared minus 2. And the final answer is 20 minus 2 is 18. minus 4x squared. Makes sense? Is it clear? Who will do the second one? Number 2. G circle f of x. Who will do the second one?
So it's g of f of x.
Nice. And this
So
is what
it's,
equal?
G of 4x minus 2.
Perfect. Nice. Then
Which is equal
plug this
to,
one inside the G.
yeah, 5 minus parentheses 4x minus 2 and parentheses squared.
Nice. Now this is equal 5 minus square this first one square 16x squared minus 2 times this 2 times 4 is 8 times 2 is 16 times x plus 4. Now you distribute the minus inside the parentheses. 5 minus 16x squared minus times minus is positive 16x minus 4. Simplify 5 minus 4 is 1. You get minus 16x squared plus 16x. 5 minus 4 is plus 1. Any question for this one? Is it clear how we think about this composite function? Here we distribute the minus inside the parentheses. And here, to find this one, like I using from the first chapter, a plus b squared, this is mean the first one squared, plus 2 times the first one times the second one, plus the second one squared. This is the formula. Okay. Anyone has a question? So this is called the composition of functions. Now let me give you another example. So the second example is for the composition function, but so the example number 2, suppose f of x equal 2x minus 4, and the second function is g of x equal 3 minus x squared. First question, find f circle f of 2. Second example is second part of this question. This is the first part of the question. Second part of the question is find G circle G of 1. Third part of the question is F circle G of 1. Who will do the first one? So I have function F, have the function G. First one, find F circle F of 2. Now I give you a number. Yes, Noel.
Okay, so it would be 2 times I think 2 times 2x when and minus 4 replace that x with 2. Yeah, 2 times x minus 4.
Uh,
Yeah,
so listen, can we do it? Can you do it step by step?
okay, so
This is what equal f
yeah.
what?
f
F of 2, right?
f of 2.
Okay. Yes. Plug that 2 here.
And then, yeah, 2x, well, 2 times 2 minus 4, because f of
Minus
2 replaces
they,
x.
they give me 0,
Yeah, 0.
right? Nice. So 0. Plug the 0 again. Again inside the function.
And it just becomes negative 4.
2 times 0. Yes, exactly. Thank you. Thanks a lot. So they give me minus 4. Because 2 times 0 is 0. They cancel. Okay? So the answer is negative 4. Now for second one, who will do the second one? G circle G of 1. This is again G of G1. Who will continue? So again, you plug the 1 inside the function G. You plug the 1 inside the function G. What do you get?
2.
3 minus 1 square.
Yeah, so 2.
I get, yes. G of 2, right? Okay. Then you plug the 2 inside the function again. Oh, sorry. Can you hear me?
Yeah.
Okay. So the function is here, the example again. So f of x is 2x minus 3. G of x is 3 minus x squared. First one is f circle f of 2, number 2, g circle g of 3, f circle g of 1. So the first one here, f circle f of 2, you plug the 2 is equal f of 2. You plug the 2 inside the function f, I get 2 times, here's 4. So here I get f of 0, and you plug the 0 again, you get minus 4. For the second one, g circle g of 3, g of 3, you plug the 3 inside the function, g 3 minus 9. I get g of minus 6. Now, what I have to do, we stop up to here. Now, what's g of minus 6?
Negative 33.
33, yes. So he plug again the minus 6 inside the function. I get 3 minus 6 squared. Give me 3 minus 36. And they give me negative 33. Now for the last one, 3. Who will do the third one? F circle g of 1.
Okay, so I can, it would be f of 3 minus
F
squared.
of g of 1, right?
Yeah.
Let's do it step by step.
Yeah.
What is g of 1?
3 minus 1 squared.
3 minus 1 squared. 3 minus 1 squared. What they give me?
And then
F of,
f of 2.
okay. You plug the 2 inside the function.
Yeah, and then it becomes negative 4.
4 minus 4, right?
Yeah.
2 times 2 minus 4, they give me 4 minus 4, and they give me 0. So the answer for F circle G is 0. Any question so far? Is it clear how to find the circle of the composition function? So again, F circle G of x is F of G of x, and G circle F of x is G of F of x. And you just using this formula for any question. Okay, so the section is finished up to here. Now let's go to the new section 2.8. The inverse function 2.8 is one-to-one function and their inverse. one-to-one function and their inverse. Okay, first of all, have you heard about the definition one-to-one? What is the meaning of one-to-one? Anyone hear about the definition one-to-one function? What is the meaning of one-to-one function? Okay, so I'm going to start to define what is the mean one-to-one function. If you never hear about the definition, one-to-one function is mean is a function, first of all, such that every element on the domain takes different element on the range. Is a function. This is like general definition. I'm going to explain this by diagram after this. So is a function such that every element on the domain takes different element on the range. Okay, so every element on the domain takes different element on the range. Let me explain what does that mean. So I have, suppose I have two sets. This is the first set here, in black color. Okay, so I have two diagrams. I'll explain by using the diagrams. Okay, this is the first here, the second one here. Okay, suppose I have here 1, 2, 3, and here 4. Is it like a linear function? Linear function is one-to-one function. Exactly, Martin. You mean that any x value cannot repeat? No, I mean like every x value takes a different value of y value. I explained that by this diagram. Every x value takes a different y value. No repeat for the y value. So here's 20, here is 30, here is 60, and here is 70. Suppose 1 goes to 30, 2 goes to 20, 3 goes to 60, and 4 goes to 70. And for the second one, suppose I have 1, 2, 3, 4, 1, 2, 3, 4, and here I have 10, 20, 30, 10, 20, 30, 1, 2, 3, 4. So 1 goes to 20. Three goes to 10. 2 goes to 20, and 4 goes to 30. So look for the first diagram. 1, for the first diagram, number 1 goes to 30. 2 goes to 20. Number 3 goes to 60. Number 4 goes to 70. Look to the second diagram. 1 goes to 20. 2 goes to 20. 3 goes to 10. And 4 goes to 30. This function is one-to-one. Why? Because every element in the domain 1, 2, 3, 4 takes different element in the range. Look, 30, 20, 60, 70, different element. No repeating elements. Every element 30 is different about 20. 20 is different about 60. 60 is different about 70. So this function is one-to-one. Is one-to-one function. But here, look, 1 goes to 20, 2 goes to 20. That's why the function is not one-to-one. 1 takes the 20, and number 2 takes also 20, because is not every element in the domain takes different element in the range. This is mean it's not a one-to-one function. It's not one-to-one function. Okay, so this is not a one-to-one function. Why? Because every element in the domain takes, like number 1 takes 20 and 2 takes 20. This is not different. Makes sense? Okay. So this is the general idea for how to find the one-to-one function. Now we're going to check if the function is one-to-one. For example, if I give you any function, I ask you, this is a function is one-to-one, and we don't have to draw a diagram like that. So I give you steps how to find this function is how to check this function is one-to-one. So to check the function is one-to-one by two things. First one is the definition. And the definition says, if I have 2 points, if f of x1 equal f of x2, then I have to check, is x1 equal x2? If x1 equal x2, then the function is one-to-one. Second way to check is the function is one-to-one by using the horizontal line test. Horizontal line test. What is the horizontal line test? Is like a line. This is using the horizontal line test. We use this one for only for graphing, for if the function is given as a graph. So let me give you the definition. So if the horizontal, so for example, horizontal, this is mean if the horizontal line if I have a horizontal line, for example, this horizontal line intersect the graph of the function only at one point. So the horizontal line test, if I have a graph, for example, I can check the graph is one-to-one function or it's like not one-to-one function. By drawing a horizontal line, I check this horizontal line intersect the graph only at one point. If it's at one point, so the graph is one-to-one function. If it's more than 1 point, will be not one-to-one function. Let me give you example how to check the function is one-to-one or not. So the example is by using the horizontal line test is f of x equal x cubed 1-to-1. Second one is f of x equal x squared 1-to-1. So to use the horizontal line test, I have to graph the function. Then after I graph the function, I use the horizontal line to check is the horizontal line intersect the function only at 1 point or more than 1 point. If it's at only 1 point, this means the function is one-to-one. If it's at more than 1 point, this means the function is not one-to-one. Okay. So for the first function here, we know how to graph the first one, f of x equal x cubed. So how is the graph for f of x equal x cubed? So we know the graph for the f of x equal x cubed is going to be something like that. So now to check this function is one-to-one, I have to draw. Let me use different color here. Yes, Angel, he said 1-to-1. So I have to check if it's 1-to-1 by using the horizontal line test. I have to draw a horizontal line. Then I have to check is this line intersect the function at only one point. As we see here, the horizontal line test, the horizontal line intersect the function at every point at only one point. Look. So this is mean the graph is a graph of 1-to-1 function. So yes, it is a graph of 1-to-1 function. So the first one, yes, this is true. Is 1-to-1. Now for the second one, the function for the second one is f of x equal x squared. What is x squared? How is the graph for x squared?
It's like a V.
It's like a u, right? Yes, v, it's the absolute value. This is nice. So the v, it is for the function f of x equal the absolute value. But for f of x equal x squared, it's look like a u. It's like a parabola. So the parabola here, the graph, it would be look like something like that. So this is the graph for the function y equal f of x equal x squared. Now this is a 1-to-1 function. I have to check by using the horizontal line. This is my horizontal line. Now I move it up. I see this line intersect the curve at 2 points. This is the first point. This is the second point. And the same thing is down. First point, second point, and here and here. What does that mean? This mean is not a 1-to-1 function. So no, it is not a 1-to-1 function. Why? Because it failed in the horizontal by using the horizontal line test. It fails in the horizontal line test. Okay, so now we can know this graph is for the 1-to-1 function or is not for 1-to-1 function. So we do the first one, we did the first one, and also we did the second one. Any question? Anyone has a question? Is it clear? Okay. So now, if it's no questions, now let's go. Let me give you another example, but this example is not like a graphs. like function, I'm giving you, like I'm going to give you a function without the graph, and I ask you, this is, by using the definition, is it a one-to-one function or not? What definition I mean? This, f of x1 equal f of x2, I have to check, is x1 equal x2? If this satisfy, this means the function is one-to-one. And I use the horizontal line test by using the example, this example. Now I'm going to give you example for the first one by using the definition. So the example is now by using the definition, which definition? I mean, like if f of x1 equal f of x2, then x1 equal x2. The question is, show the function f of x equal 3x plus 4 is one-to-one function. Anyone has any idea how can I start solving this one? How can I show this function is one-to-one? I'm going to use this formula. I have to plug f of x1 equal f of x2. Then I have to check, is x1 equal x2? If x1 equal x2, this means the function is one-to-one. Anyone has any idea how can I start solving this question, this example? Okay, let me do it. Let me do the first step. To check this function is one-to-one, I have to plug x1 inside the function, x2 inside the function, make them equal. So I have to write here f of x1 equal f of x2. I plug x1 inside the function, I get here 3x1 plus 4 equal 3x2 plus 4. Now I have to solve these equations, and then in the end here, if I find x1 equal x2, then I said, yes, this is a one-to-one function. Okay? Now, how can I solve this one? What I have to do in this step?
Subtract 4 on both sides.
Nice. Then what I get here, it canceled.
Yeah, 3x1 is equal to 3x2.
3x2. Nice. Then
Divide both sides by 3.
okay,
Cancel.
perfect. So divide 3 times 3. Again, it cancelled again. This cancel, this cancel. What I arrived here? I get now x1 equal x2. And this is what I need. This is mean the function of x is one-to-one function. So the function f of x equal 3x plus 4 is one-to-one function. Why? Because I starting by f of x equal f of x1 equal f of x2, I keep subtracting and canceling for some element until I get x1 equal x2. If x1 equal x2, I arrive at here, This means the function is 1-to-1. Any question? Anyone has a question? How to check this function is 1-to-1? So this function is 1-to-1. Yes. It's clear. Okay, now let's go to the inverse of our function. So we start this section. This section is two part. 1-to-1 function. Second part, the inverse of this function. We finish the 1-to-1 function. I give you the definition for 1-to-1 function. And I give you the general idea. Then I have to check which function is 1-to-1 by using the horizontal line test or by using the definition. I use the horizontal line test by drawing a horizontal line here. I see here the horizontal line intersect the function as the graph of the function at 1 point. And I said this is a graph of 1-to-1 function. But because the horizontal line intersect the graph at 2 points, this is mean not 1-to-1 function. Then I give you example by using the definition, how to check this function is 1-to-1. Then I find this function is 1-to-1. Now I'm going to this next part of this section is the inverse. So now the inverse of the function. So let me first of all define what is the mean of inverse of the function. So let f be a 1-to-1 function. So the function f must be 1-to-1. So to find the inverse for any function, the function f must be 1-to-1. If it's not 1-to-1, so it doesn't have inverse. This is so important. Function must be 1-to-1. If it's not 1-to-1, then the function does not have inverse. Let f be 1-to-1 function. Now the inverse function is defined as, if I have, for example, y equal f of x, so the inverse, taking the inverse for both sides, I get f of inverse of y equal x. So this is the definition of the inverse. Okay, again, f must be 1-to-1 function. If it's 1-to-1, I can't find the inverse. If it's not 1-to-1, I cannot find the inverse. Second things of this definition, so the second things we have to know, the domain of the function f is the same as the range of the function f of inverse. And the range of the function f is the same as the domain of the f inverse. This is most important two things we have to know. Okay, domain and the range. The domain of f is the same as the range of the f inverse. The domain of the function, the range of the function is the same as the domain of the f inverse. So if I ask you, for example, what's the domain for the f inverse? You go to the range of the function f. If I ask what's the domain of f, you go to the range of f inverse. Okay, let me give you an example after I give you all this information. So the example is, suppose I have let f of 1 is equal 5, f of 3 is equal 7, f of 8 is equal, for example, 10. Find f inverse of 5, f inverse of 7, and f inverse of 10. Who will do the first one, second one, third one? By using this definition, y equal f of x, f inverse of y equal x. Who will do the first one here? What is f inverse of 5? By using this information, I have f of 1 is equal 5, f of 3 is 7, f of 8 is 10. The question is, find f inverse of 5, find f inverse of 7, f inverse of 10.
F inverse of 5 is 1, right?
This is true. F inverse of 5 is 1. I tell you why. By using this definition, y here, y equal f of x, y is 5, and x is 1. F of 1 equal 5. This is my y. This is my x. Now f inverse of y equal x. This is mean f inverse of 5 is gonna be x. That's why the answer here is 1. Just applying this formula. Now for the second one, f inverse of 7.
Then it would be 3.
3. By using the same idea, f of 3 is 7. This is mean f inverse of 7 is 3. So here is the 3. Now for this one, what is f inverse of 10? By using this one, again, it's gonna be 8. Same idea. F inverse of 5 is 1. F inverse of 7 is 3. F inverse of 10 is 8. Okay? Any question so far? Okay, next one. Give another example. So my example now, suppose I have a graph look like this. This is my graph. This is y-axis. This is x-axis. It is 1. It is 2. Theory. 25 here. $35. Okay. So the question now, find f inverse of 50. F inverse of 30 and f inverse of 25. Who will do the first one? Second one, third one. Okay, let me do the first one. Hold on, not theory, I mean something wrong. Hold on, not theory. Here we have 35, I mean 35. Here we have 25. Here we have 30. Okay, I'm going to do the first one. So when the question asks me what is the f inverse of 35, I have to go to the y-axis, looking for 35, then I have to find the x value for this value. So to find the x value for this one, I have to draw a horizontal line, something like that, and I check where's this intersect with the curve. This intersect the curve at this point, then I have to find the x value. Then I have to find the x value for the intersect. So it will be like this around here. So the x value here is 3. Okay, this is mean f inverse of 35 is 3. So here is 3. Who will do the second one? Same idea exactly. What is f inverse for 25? Okay, draw a horizontal line at 25. Here's 25. You see where is this line intersect the curve at this point. So you found the check the value. It's around here, like 1/2, around 1/2. So the answer is 1/2. 1/2. Why this is 1/2 here, 1/2 here. Okay. For the last one, who will do the last one? F inverse of 30.
1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2
think we can do that one, right? Because there's two values for 30.
For 30, the curve like
My bad.
around here. Yes, it's look like
It's not 1-to-1.
it's not one-to-one function. I mean, here the graph is not exactly like this.
No worries, I couldn't tell. I mean, it's at 3, right?
It
F
has
inverse
two
of-
values. It's 3 and 1, but this is not one-to-one function. It must be one-to-one function. So the graph I'm changing. I'm sorry for that. So suppose my curve look like this. Let me give you another example because this is the wrong example. Sorry for that. Now the same things, but I'm going to change the curve. The curve, instead of the old one, it's going to be something like that. Okay. Now at 35, here is the 35. It has to be 3, like this. It's 3. At 25, here is 25. It's supposed to be half, 1/2. Like around, it's not a half, it's 1. Here it's 1. I'm going to change this one here. This is 1. So here is 1. Here is 1. So for the last one, the same idea. For f inverse of 30, what's the answer? I draw a horizontal line at 30, and I see where is the intersect with the curve. It's around 2. So the answer is 2. Anyone has a question? How you think about example like that? By the way, it is a Wobosine question. This is a Wobosine question. Make sense how you think about that? Okay, how explain again? So the question is find f inverse of 35. So you have to draw a horizontal line at 35. I draw a horizontal line. This horizontal line intersects the curve at this point. I have to find this point. What's the x value at this point? I have to draw a vertical line, and the vertical line it's look like 3. So the answer is 3. For the second one, f inverse of 25, I have to draw a horizontal line at 25 and find what the intersect of the curve. It's look like here at this point. So then I have to draw a vertical line to see what's the x value. The x value, it's look like 1. So the answer is 1. For the last one, f inverse of 30, I have to draw a horizontal line at 30. Then I look at what I have to draw a horizontal line at 30. It's intersect with the curve at this point. Now I have to find the x value at this point, draw a vertical line. It shows like around 2. So the answer is 2. Make sense? It's clear now? This is the question. The red line, it's the curve. It's my function f. Is the f. This is my curve. This is my f inverse. No, I mean for f is not f inverse. It's f. So this is f of x. The red line, it's the f inverse, the function f. The question is find the f inverse of 35. I go to the y values in the y-axis. We're trying to find the x value of the x-axis. Is it clear? Okay, before I end this class for today, I'm going to give you the last property. Is called cancellation property. And next time I'm going to explain more for this cancellation property. So cancellation property. So suppose I have a one-to-one function. Let f be a one-to-one function. This function is one-to-one, and let f inverse be this notification be the inverse function of f. Then the cancellation property says f inverse circle f of x is equal f inverse of f of x. Then this is equal x. If I check this function f inverse circle f, and they give me x, this is mean the function f and f inverse are inverse to each other. And the same things for f circle f inverse of x must be equal f of f inverse of x, and this give me x. If these things give me x and these things give me x, this means this function and this function are inverse to each other. Okay, this function and this function are inverse to each other. So I'm going to give you example, and we keep it for next time for solving. But if you want to think about this one, show that f of x equal x cubed, and the second function g of x equal x to the 1 over 3 are inverse of each other. So how can we check? By using this property. If f circle g of x, they give me x, and g circle f of x, they give me x, this means this function and this function are inverse to each other. Next time we're going to solve this example. Anyone has a question so far? Okay, we're going to stop up to here. See you next Thursday.